Hi guys. For today's lesson, we're going to talk about return values functions and how to use functions from modules, which is a pretty useful thing in Python. There are a lot of modules available for Python that you can use. It's one of the strong points of Python, both centrally developed and user developed. So again, a void function is a group of statements within a program performing a specific task. So we call the function we need to perform the task. So if we have a value returning function, it's similar to a void function. In fact, they're declared exactly the same. There's not any difference in declaration. The only difference is we return a value at the end of the function. So the value returned at the end is returned when the function stops executing. So we use the return statement and we return the value. So if we want to look at an example of that, we can go back to our pie example that we're looking at earlier. You see here I return a value a, and that value is the return value for this function. So I compute the area inside this function, and let's get rid of this nasty global here, and this redefinition of pi. So I calculate the area of this circle given the radius, and I return that value back. So I can actually return multiple values when I do this. So the way that I do that is I just put a comma in here. So I can say a comma 45. All right, so now I'm going to return two values in this function. And if I want to get those values out, what I would do is something like a comma b equals area, let's say 1. So, and then let's print a, and let's print b. All right, so we can return one value, or we can return multiple values. We run this program. We're going to see what happens is, so we print a is 3.14, which is what we'd expect with a radius of 1, and then b is 45, which is the second parameter that we return back, the second return value. So we can return one return value, or we can return multiple return values in our function. And if we return multiple, we have to include this comma and several variables, to basically one variable per return value for our function. So that's pretty straightforward to do. We've seen functions that do this before. So a standard library of functions is a library of pre-written functions that come with Python. There are a lot of these that do a lot of different things. There are some functions that sort of come built into the language itself, and so the interpreter automatically builds it in. We just call the function. Things like print, input, range, those are all library functions, but they're built into the language. In some cases, though, we have to import. We have to use the import statement to import that library into our code. So when we use the import function, what we do is we say import and then the module name. And so what a module is a file that stores the functions of a standard library. So basically, it lets us group our functions into. So we don't have to include every function that might be in existence when we include things. Let's say we just want to do some math, so we can include a math function. Let's say we want to just do random numbers. We include a random number function, but we can use the import statement to control what we bring in from a module, which modules we bring into our function that we plan to use in our particular code. So the syntax for that is import and the name of the module we're going to import. You write this at the top of the program. You always write these things up at the top so you can see sort of what the dependencies are. What modules does this code depend on? That can be really important. So we always write these things up at the top of our program. So we look at the library as a black box. We don't know how it works inside. All we know is what it does when we call the functions. So we have our library functions. They have an input. They have an output. What it did in the middle, I have no idea. But I know if I give it an input, it's going to give me an output, and it's going to compute whatever it says it's supposed to compute. So random numbers are useful in a lot of programming tasks. You write games, like in our first assignment in our dice game, we need to use random numbers to generate the dice. So the random number generators in Python are included in the random module. So these are all the functions for working with random numbers. So when we want to include the random module, we just type in import random. and that will give us access to all the random functions in the random module. So we want to call a function that belongs to a module rather than just calling the function name. To specify that it's the function from that module, we use the syntax module name function name. So for example, so here's a very useful one. In fact, this is probably the one you're going to use in your in program 2, and that's the randint function. So the randint function generates a random number in the range provided by the arguments, and it returns a random number to the program that called the function. The returned integer can be used anywhere that an integer can be used, and we can play around with this. In fact, we can go back up here, and we can use import random, right? So it's gray because we haven't used it yet, but we're going to use it. Let's say instead of having our area be 1, we want to have a random area. So we can say radius equals random dot randint 1 comma 10. So what this is going to do is it's going to generate a random number between 1 and 10. So we can, well, let's go out and take this trash out, right? We don't need this stuff in here anymore. We're not talking about multiple return values. We're just going to have 1, and then let's print out the radius. All right, so now what our function is going to do, we still have our constant pi up here, right? We're going to declare a new variable called radius, and we're going to set it equal to a random number generated between 1 and 10 from this library function. Then we're going to calculate the radius of a circle, the area of a circle with this randomly generated radius, and we're going to print these things out. So we see when we run this, we get 50.24 for the area, and then the radius is 4. We run this again, we get a different radius and a different area, and every time we run this, we're going to get a different radius and a different area. But the radius that's going to generate is always going to be an integer between 1 and 10. So this is how we use a library function, for example, to generate random numbers. So here's another example. It shows you the syntax. Number equals random.randint 1 to whatever. You want to generate the numbers in between. So this randint function is going to generate a random number, and it's going to assign it to the variable that we set it assigned to. We can also print these things, and we can either assign it to a variable, and then we can print the variable, or we can print the result of the function call directly. So in this case, in figure 5-222, you see that they just call the function inside. Whatever gets returned by that is going to get printed. So there's some other functions for doing these things. So there's a randrange function that returns a randomly selected integer from inside the resulting sequence. So there's a sequence, it generates a sequence similar to range. In fact, it has the same arguments as range. It's going to generate that sequence, and then it's going to pick a number from that sequence, a random number from that sequence. There's the random function, which is not the randint function, but the random function, and that is going to return a random float between 0 and 1. So that one doesn't have any arguments. It's just going to return a float between 0 and 1. There is the uniform function, which also returns a random float, but allows the user to specify a range. So if you remember from statistics, a uniform function, a uniform distribution, is a distribution for the probability of all the numbers in the middle are equal, right? So it's basically, it's just like a kind of like a toy cost, but not really, because you got multiple numbers. But it's going to randomly generate a number in that range uniformly, meaning there's no preference for any particular number. They're all equal likely to come out. All right. So random numbers are not actually random in programming for the most part. They're actually what are called pseudo-random numbers. Pseudo-random numbers are numbers that we generate via a formula, and they look random, but they're not actually random. So the random numbers are generated by this come in a sequence, and so the starting position of the sequence is called the seed. So the seed initializes the formula that generates the random numbers. So to get different sequences of random numbers, we need to use different seeds. By default, the system time is used for the seed. We can use random.seed to specify a specific seed value. So let's say, for example, you want to generate the same sequence of random numbers every single time. You can specify the seed, and it will it will generate the same sequence of random numbers every time because it always starts from the same seed value. Um, Seems a little bit odd, but there are uses for this. You know, if you want to if you're looking at, say, some sort of numerical formula and you want to be able to reproduce the values, um, then you want to be able to specify the seed because otherwise you can't reproduce. Um, but by default, if you don't specify a seed, if you don't use the seed function, it'll use the system time and it'll seed it for you. So we don't have to worry about this too much. Most of the time, we're not going to specify a seed. If you want to, you can specify a seed. All right. So that's it for random numbers and using libraries. We're going to continue on with writing your own return value functions in the next lecture. Thank you for watching.